remember, sorry about anyways, YouTube thing. Alright, so remember 41 multiplied by 351, the cross multiple of 41 to 351 subtracts the cross multiple of 657 to 1. That's what we did for A1, and that's that whole thing divided by 41. Now, to complete this step for this A2, this part 2 here, simply 41 times 810 plus 0.4k minus 0 times 1, which is just simply 41 times 810 plus 0.4k. Okay, so let's just write this down so you can understand what I'm saying. So 41 multiplied by 810 plus 0.4k subtracts, and see that? 0. Divided by the lower left hand, cross multiple values that you use. So that's 41 in our case. Divided by the whole thing by 41. What does that turn out to be? It's just 810 plus 0.4k. Simple as that, man. Alright, so always set a program in your mind that automatically executes. When you get to this A2 section in your Routh criterion table, you just simply put this term right here without doing any derivation or anything like that. So 810 plus 0.4k. Now this section here, like you guessed, so 41 times no number there's nothing there, and that nothingness times 1, that doesn't even make sense. So what do? Just cross it out. Just cross this bit out. Done. So we get to B1. B1 is A1 times, blah, 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 understood. Moving on, so B2 is, now, that's going to be 0, because remember, there's no values here. So that's just 0, and there's no values there, so it's just imaginary, cross that out. This bit here, it's going to be same as A2. It's going to be the exact same as A2. Why? Because watch, B1 times A2, B1 times A2 subtracts A1 times 0 divided by the lower left hand, which is B1 in our case. And what happens? Sorry, my bad. What am I doing? The lower left hand, which is in our case A1. What does that do? That sorry, 1 second. A1 657. Okay, I just confused a few things here. 1 second. Alright, so the lower left hand in our case is B1. My bad. It's a bit messy around these bits anyway. So the lower left hand for our let's just call this C1 in the Routh criterion table. The denominator is going to be B1. Okay, so you notice the B1 cancels with the B1. You don't even have a term here that's 0, and you're just left with A2, and A2 is this term here again. So like I said before, you just throw this over here as C1. So try to memorize that A2 and C1 are going to be your constant value. If you understand what I mean, this is your constant. This is your constant, same as this guy right here, constant, okay? So memorize that, guys. It's important. If you couldn't catch what I said, try to rewind and just quickly catch that very important phrase that I'm mentioning, because that is like a fundamental theorem for Routh's criterion to follow. And through and throughout, these are just all dashes and imaginary values, nothing there. Now, to actually analyze the value of k and to find stability for that, moving on to, let's just find this clean part here. Okay. All your terms in the second column here have to remain the exact same sign as the initial term. Understood? So there's a plus here, correct? There's another plus. There's another plus. There's another plus, and there's another plus. They're all positive, right? Well, you could be wrong there, because we know that these constants are pluses, right? But these unknown values here, A1 and B1, you don't even actually know whether or not they're positive or negative. So too this term over here. Why? Because there's a K term. And this K term, you have to analyze it via basic mathematical manipulation of limits. Okay? So, every term began positive for us here. So we need to keep our K values positive. That is the theorem that we've derived for now. So let's just start with our bottom term here. 810 plus 0.4k must remain positive. How do we mathematically represent that? The greater than sign. Greater than 0. So simply just rearrange. K is greater than 810 divided by 0.4, which is K is greater than negative 225. Well, what about A1, B1? Let's just quickly substitute these A1, B1 values. So, oh yeah, by the way, we got the lower limit. That's for certain. Or that could be upper, you never know. So you got your limit here, but we need to complete this via calculations of A1, B1. So A1 is 41 times 351 subtracts 657 multiplied by 1. If you didn't understand why I did this, please just check back in the video to see as to what I'm actually doing. A1 then actually equals 300, or that'll be roughly 3334.98. Okay, I'm just roughly roundabouts there. Therefore, B1 equals A1 times 657 subtracts A2 times 41 divided by A1. Okay, so let's quickly write that down. Let's represent that mathematically. A1 multiplied by 657 subtracts A2 multiplied by 41 divided by A1. Remember, A1 is 334.98 and A2 is 810 plus 0.4k. Simplifying this down, sorry guys, I'm skipping a lot of steps as I have to rush this final section of the video. You get a final value of a linear equation of 557.9 subtracts 0.04896k, and this must be greater than 0. Manipulating this mathematically, we then get negative 0.04896k is greater than negative 557.9. Remember, in the laws of limits in discrete mathematics, to switch these signs and remove the negatives, you have to inverse your limit sign. So therefore it's less than now 557.9, and the signs change on both sides. Therefore k is less than 11,395. Yep. Alright. So therefore, answering question B, upper limit of 11,395 and a lower limit of negative 2,025. This is a range of stability for characteristic equation of a closed loop transfer function via the k value. This is the range of stability of that k value, okay? And that answers our question here. Using Routh criterion to determine the values of k for which the closed loop transfer function would be stable. Okay, ladies and gentlemen, thank you for watching. I'll be posting another video soon, hopefully, and just be discussing more advanced theorems of control systems. And we might even be moving on to the second level up of mechanical design, moving on to mechanical design 336, which is third year mechanical design. Okay, thank you for watching. Bye.